This video will explain why a particular perpetual motion machine doesn't work. And in doing so, it'll also teach you about buoyancy. Before continuing, I'd like you to go down to the description box and click on the link to a picture. This picture shows the perpetual motion machine that of course doesn't work, because no perpetual motion machines work. But many people don't understand why it doesn't work. Before talking specifically about this machine, I'm first going to explain some basic physics. First of all, even when a fluid is at rest, its molecules are moving in all directions. For example, if you put some dye into a tank of water, the dye will slowly spread out. This happens because of the random collisions that occur between the water molecules and the dye molecules. One important thing to understand is that in a tank of water, where there's a thermal equilibrium and there's no macroscopic motion, just as many water molecules are moving left as are moving right, and just as many are moving up as are moving down, and so on. If there's a solid object in a fluid, so let's say that is the solid object, there will be a pressure on the outside part of it due to the fluid molecules. So each ball represents a fluid molecule, and the arrow represents its velocity. So this molecule is moving in this direction with a particular speed, and here's another molecule and another one here, and so on. Each time a fluid molecule hits the solid, there's a force, and this happens so many millions of times every second that the solid object feels it as a constant pressure. In the presence of gravity, the pressure in a fluid increases with depth. So if this is a fish tank here, and it's full of water, nothing but water, and this is just an arbitrary volume of water. It's not a solid object, it's just a volume of water. There will, of course, be a force of gravity, and just talking about in the vertical direction, there will be molecules hitting the top of it, pushing it down. So I'll draw it like this, and there will be other molecules hitting the bottom, pushing it up. If the pressure were constant on all sides of an arbitrary volume of fluid, then it would sink due to the force of gravity, and it wouldn't be at rest. Therefore, for a fluid to be at rest, the increase of pressure with depth must perfectly balance the weight of the fluid. So basically, the force of gravity plus the pressure on the top half of this arbitrary volume of fluid is exactly equal but opposite to the upward force from the pressure on the bottom of that cube, and that's why there's no macroscopic movement of water. So any solid fully immersed in a fluid will be acted on by the force of buoyancy. This force is due to the increase of pressure with depth. The fluid molecules hit the bottom harder than they hit the top. If this force is greater than the force of gravity acting on the solid, it floats. If the force is less than the force of gravity, then it sinks. And if they perfectly balance, then the solid object just remains stationary. However, if there's a fish tank with a hole in the bottom, and there's a rope that extends below the bottom of the fish tank, and also above the top of the fluid, then there will be no vertical force on that rope. This is because there's no bottom of the rope that the water molecules can impact. There might be one water molecule moving like this, and another like that, and another here, and another there, and so on. And the only thing these water molecules can do is compress the rope, but they can't push up on it, and they can't push down on it. And now I can explain why the perpetual motion machine doesn't work. So if this is a tank of water, like the one that you can see in the picture of the perpetual motion machine, and this is one air-filled ball, and another one here, and final one here. Let's say the water level is right here. Okay, now we'll take a look at the forces of buoyancy. The force pushing down on this bottom ball is greater than the force pushing up on the bottom half of the middle ball. And the force pushing down on the top of the middle ball is greater than the force pushing up on the bottom half of the top ball. So what will happen here is that these balls will move down a little bit and then come to a point of equilibrium and stop moving. And so the perpetual motion machine will not work. If you have any questions, then post them in the comments section below.